Hello and welcome to this video. Today we're going to learn how to operate a FOTRIC articulated lens camera. So let's start by showing you how to remove the battery and replace it for a fresh new one. The battery comes with two buttons, one in the front part and one in the bottom part, right here. We need to press the two of them at the same time and then we can remove it. With the fresh new battery, I'll bring it, plug it in, and go all the way until I hit the click. Now let's talk about how to swap lenses. If you have purchased a thermal camera like this one and you have multiple lenses for different applications, this is how you do it. First, we're going to ensure that the camera is turned off, that we're doing this indoors to prevent dust to fall into the detector. First, we're going to pull down the latch, we're going to press slightly and turn counterclockwise the lens, and then we're going to gently remove it. Once I have done this, I can cover this part of the lens to ensure that it's protected and bring the new one. When I bring the new one, I will identify this red dot on the inside part of the lens. You will also see that in the camera there is a red dot in this area. I'm going to align those two red dots until I find the place where the lens falls inside without forcing it, right there. Following that, I will pull the latch again, press slightly, gently, and rotate until I hit that click. To ensure that the lens is fully inserted, I can do a quick check and make sure that the latch is back in place. With this, we're ready to start the camera and do an inspection. So let's start the camera. We're going to press the power button and hold it for 2 or 3 seconds. And we're going to see the screen turning on. We're going to wait for a few seconds and let the camera get ready. In order to ensure that the camera feels comfortable to your hand, we're going to put the hand through the hand strap. But first, we're going to open, make sure that the knuckles pass the strap, that I have a full grip of this area of the camera, that I can reach with my index the front two buttons, and that I can also use my thumb to reach these buttons, directional buttons. So once again, I'm going to go all the way. I'm going to make sure the hand strap passes my knuckles, and I'm going to make it tight. Maybe not too tight. The idea is that the hand feels that is properly fit and that this hand strap offers additional support. Now, the camera is designed to rotate 180 degrees completely. It's a camera that can be used with 2 hands or with a single hand. Okay, so we're ready to start an inspection. The first step is to open the lens cover. These can also be adjusted to open on the side or on the bottom. And now we're going to start operating and navigating the different parts of the interface. To take a good image, I need to make sure that the camera is in focus. This is one of the few things that cannot be modified during the post-processing stage. I can either do that by adjusting the focus ring or by pressing the automatic focus button. I only need to press once and wait until the camera has reached the focus. After that has been done, I will press the picture taking button that will freeze an image so I can modify it. Once satisfied, I can press it once more to save the picture. Let me show you how to do it. First, we need to open the lens cover. We're going to aim at our object of interest. If I desire to use the manual mode, I can use my index finger to adjust the focusing ring. You will see in the image how we go from blurry to a sharp image. If I use the autofocus, I will press the button once, and I know the process has been completed when the 2 brackets disappear from the screen. I will press the picture taking button to freeze my image, modify in different ways, and then I can save the picture. The autofocus on the camera works in different ways. I can see here in the main menu, settings, device set, focus modes. The autofocus can either use contrast thermal, which is the one that I was using previously, or laser distance. The laser distance employs the laser measurement device that is in this part of the camera to calculate the distance between the camera and the object. This is commonly used for large assets or building inspections. It is not quite recommended for transmission lines, especially if I'm not operating with a telephoto or ultra telephoto lens. When the camera is using laser distance and I press the autofocus button, it will activate the laser measurement device and you will see there's a little dot now in between the brackets. I'm going to get the camera out of focus first, press the button, and you will see that laser is a red dot pointing in the object of interest. I will go back to device set, focus. For today's applications, I will use the thermal contrast one. Now, the third option for autofocus on a FOTRIC camera is touchscreen focus. If I activate that and my camera is out of focus, instead of adjusting manually until I get the focus that I desire, I can simply tap on the object of interest and let the camera get in focus on that specific object. This is particularly useful in situations like this, where I have components at different distances and I want to focus in one or the other. Professional thermographers will always prefer the manual focus because the autofocus might focus on objects they're not interested in. So by tapping on the second object, the camera will adjust the focus to that one, or I can come back to the one of interest. The other parameter that needs to be adjusted properly before taking any picture, because it cannot be adjusted after the picture is taken, is the temperature range of the camera. Right now I'm between -4 and 248 Fahrenheit. I have purposely adjusted the emissivity of this spot to simulate a temperature that is above my temperature range. I know that the temperature reading I'm getting here is not accurate because right on the corner it says that is greater than 248. In order to make sure that the camera can measure that, I will go to the main menu, settings, temperature measurement range, and then I will adjust to a value that fits my specific temperature of my object of interest. You will hear the camera clicking, letting you know that it is adjusting internally. Now the camera can properly measure those 400 degrees Fahrenheit. The idea is that every time we do this, we try to work with the smallest temperature range possible to increase the accuracy of the measurement. I can also use the intelligent range. The camera can be accessed to all the menus from the touchscreen or from the directional buttons. I can tap on the three dots on the screen, find any of the sub-menus, or go to the settings just by tapping on the screen. I can also do the same by tapping or pressing on the center button and navigating across the interface. This is particularly useful during winter times when I'm using gloves and it is hard to use the touchscreen. Whenever I stop at an icon, I will see the name of that specific sub-menu. If I want to enter, I will press once more and I will move specifically to the feature that I want to use. I would like to show you now how to adjust the camera's parameters so that you can capture accurate measures with the camera. I will start by tapping on the main menu, move on to the second sub-menu, parameters, and I can adjust first the emissivity. I can scroll down to find the value that I need from a specific material. There is also a list of suggested emissivities for given materials. However, these are just for reference. We recommend that every time you are performing a job, you identify the specific emissivity of the material on the surface of that equipment. I can also adjust the reflected temperature, once again by scrolling up and down, the ambient temperature, the humidity or relative humidity, the distance, which can be manually adjusted, or lastly, the IR window compensation. In order to use this feature, I need to turn it on. I will provide the temperature of the optic or the air window, and I can adjust the transmission rate of the window. I must click on the center button to ensure that the feature has been activated. You will know that that has been activated because there is a little icon in the top left corner. To start a qualitative inspection or to ensure that the images that you're capturing provide additional details through color, it is important to start by using the auto temperature span. With this mode, I can move around, and as the camera is aiming at different areas, you can see how the values on the top and the bottom are being adjusted automatically. Once I return to an area of higher temperature, those values will adjust themselves, so they provide with colors that give me information. However, in components like this one, where there is a small area of high temperature, many of the details can be overlooked. That is why it is recommended that once you identify your component or area of interest, you switch to manual mode. Manual mode allows me to modify those two values manually. I will tap on the bottom to deactivate it. Now I know that the top value is activated, and then I can scroll on the screen to adjust to a value that shows me and highlights specific issues. You can see how now the mesh on the side and some of the buttons of this equipment are showing pretty much glowing. I can lock this and unlock the bottom one and repeat the same procedure. If the two of them are activated at the same time, when I scroll, what I'm doing is adjusting the level. So the two values will move symmetrically, keeping the span between the two of them. One of the preferences of professional thermographers is to always use manual mode, but these will take additional time adjusting and setting up for every point of inspection. FOTRIC cameras can also operate on auto mode and go to Settings, Device Set, turn on the TWB mode, which activates a different type of equalization on display. With this mode, the camera identifies small areas of high temperature so that the color distribution on the screen provides with more details. You can see how now TWB is activated, and I can see the temperature distribution around the hole and also some details on the side. Once again, if I go back, you will see that pretty much all the focus is only on the hot area. Lastly, the third option to adjust the temperature span and level is by touching on the screen. Right now, the interest of the camera is on this area. So these colors are focused on there. If I tap it specifically, it will narrow even more to understand the temperature distribution. But if I tap on a different area of the screen, the camera will show me different colors to help me enhance hidden problems. When I am adjusting the manual temperature span and level, I can use the directional buttons on the camera to lock and unlock the top and lower limits and also adjust the values. I can do it either on the screen, but if I do it here, by tapping on the directional buttons, I can unlock, lock, lock, and go back to the two of them locked. If I press once more, you will see how the two of them are unlocked, so I can operate them. If I go up and down with the buttons, I will also be adjusting those temperature values. This is to operate separately my upper and lower limits. I can also adjust the temperature span by simply moving this, going to Settings, Device Set, Manual Mode, switching from maximum and minimum to temperature span. When temperature span has been selected, the camera will show me the specific span between these two. So if I start moving, now you will see 84 to 88. There's only a 2.1 temperature span between those two. If I keep that directional key pressed, you will see how that value starts increasing. This is particularly useful when I want to see details that are hidden in low temperature differentials. Once again, I can scroll, adjust to provide for additional details, and see whether I want a lower span or a wider span. Switching from automatic temperature span and level and manual mode, it is a common practice when I'm running an inspection. I will use auto to scan around. Once something has been identified, I will come back, switch to manual, and start adjusting those values to get a clear picture. However, I can also set up my AI button as a shortcut to do that for me and avoid the multiple steps process. What I need to do is to press and hold for a couple seconds, find the specific feature, which is right here, switch scale mode, click, and then after pressing the button twice, the camera will start doing that as a shortcut. So right now it's in touch, but if I press again, it will take me to auto. And if I press once more, it will take me to manual mode. That way, if this is a method that I use commonly, I can avoid multiple steps by setting up a shortcut on my AI button. Let us see how to use ROIs on the camera. I will go to the center menu. I will go then to the fourth icon where I can add rectangles. These rectangles can be moved around and positioned in specific locations of the screen. By tapping on the corners, I can also resize them and reshape them. Going back there, I can also add spots. These spots can be located in different positions as well. And I can also create circles. The circles might be a better option for the application that I'm using right now. If I want to delete any of them, I will simply tap on the center, go to the menu for that specific component, and delete it. Same applies for the spot. Now, let's say that I want to do delta temperature between these two components, my area of interest and my spot. All I have to do is tap right here, go to delta T temperature, turn on the feature, and indicate what's going to be my reference. I can use a spot 1 as my reference and hit enter. Now you see that the delta T reference value is 82, which is the temperature of the spot. There is a 0 in front of SP1, indicating that there's no temperature difference between SP1 or spot 1 and itself. However, the value in front of circle 1 indicates the delta of it versus the spot. So what happens when I add additional areas of interest, like multiple boxes, a few more spots? Everything that you see on the screen, every box is calculating temperature differences simultaneously versus spot 1. So even if I move the camera around, all of them are doing calculations simultaneously. Let's say that this is my actual setup, and after adjusting the different positions and sizes and shapes of different objects, I want to take a look at what is in front of me. I can simply scroll down, hide everything, and my image is clear. However, they haven't disappeared. I can come back and see all of them. If I'm done with this type of measurement for a very complex scenario, I can go back and tap on eliminate. Let's say that I still have that circle. Right now, the camera is showing me the temperature of that circular area, but I want to know more than that. I will tap on the menu, open the ROI submenu, and tap on the display of information. I want to know the maximum temperature, but I also want to know the emissivity. This is because I can have a general emissivity that is set up right here, but I can also have local or partial emissivities for ROIs. All I need to do is tap on the area of interest, open the submenu for that area, and tap to activate the local emissivity. I'll turn it on and I will change the value to show you how the temperature changes. If I tap enter, you will see that now I have a very high temperature because it is using a different emissivity. The last type of object that I can use is a line. I can apply lines to different types of objects to identify where is the highest temperature. I'm going to eliminate this one right here, and I'm going to adjust my line over here. So right now the highest temperature on that line is on the top of the line, but as I scan across an area, I can clearly see that the highest temperature on my line is right there, where the line intersects with the hotspot in my black body. Once again, I can do different other calculations with my areas of interest. I'm going to use now a box. Boxes can be located in any position, and I can also set up alarms for each and all of them. I will tap the item, the alarm, and will turn it on. The high temperature alarm will calculate anything that is above a given value. I will tell the camera that I want the maximum temperature on that box to be compared with a given specific value. So I'm going to lower that value to activate the alarm. And if I hit enter right now, you will see a red alarm on the screen telling me that the area that I want to control. Let's say I want to inspect a given equipment that by manufacturer's recommendation shouldn't go above certain temperature. This is a quick way to do it. I can also activate the sound alarm over here. So right now it's silent, but if I move to buzzing, the camera will emit a sound. I can adjust the volume of that by scrolling down and lower the volume or bringing it all the way up. Once again, tap right here, go to alarm, and make it silent. If what I want to do is the opposite, and I want to compare the versus a lower temperature value, once again, I can show maximum or even minimum, either one, and compare. In this case, I'm going to bring to a high temperature value to make sure that it is triggered. If I enter silent or buzzing in this case, I will see a blue number, the bell blinking, and also the sound right there. You probably saw that when I scroll down, there's a Bluetooth button right here. When tapped right there, the camera will turn on the Bluetooth and it will automatically search for earphones that have been connected, where I can also listen to these alarms. I can also use the regions of interest as a way to measure areas at a given surface away from the camera. First, I need to go to the settings, storage options, and I will activate the laser distance saving onto the picture. Once it is activated, and I'll go back, the moment that I take a picture, the camera will measure the distance between the camera and the surface. In this case, is 3.28 feet. And it will tell me an estimate of the area reflected or projected onto that surface for this circle. And you can see that if I adjust the position and the size of that circle, the values of the area will also change. This is an easy way to get estimates of materials or that are needed to fix, let's say, missing insulation, or also to estimate how large a problem is compared to other at a distance. There are different ways to add additional details to the thermal picture that I'm taking. One of them is by switching the image mode. I will go to the main menu, third icon. Right now I'm on infrared mode, but I can also switch to digital camera, which will provide additional details of the environment of the inspection. I can also use the picture-in-picture. For this, it is fundamental that I focus the camera every time that I move to a different distance. I can tap in the center of my picture-in-picture and I can modify its shape, its size, and I can also move the location of it. It is once again very important that I focus every time to ensure the overlapping of the two images. The fourth mode is fusion or blending. Blending allows me to do a transparency of the thermal picture over the digital image. Right now all I see is a regular picture with zero blending, but as I increase I can see what the naked eye cannot, the heat in the setter. Lastly, this camera comes with a secondary digital camera. This camera is 13 megapixels, which is a higher resolution and also a narrower field of view to provide even for better details. That's the fifth option right here. So as you see here, it's slightly narrower, providing for a farther close-ups or close-ups of farther objects. And you can see the difference between that one and the original digital picture. There are two cameras on those two digital cameras on this camera. This one over here is 5 megapixels. It will always do the matching and blending with the thermal lens, and the 13 megapixels narrow field of view to provide for additional details. Lastly, I can do a picture-in-picture showing the two images together. When I'm taking a thermal picture, I don't necessarily need to see the digital picture to be able to capture it as well. If I take a picture right now, the camera will save only that thermal picture. But if I want to take an additional one, I will go to storage, save digital image as separate. I will tap that, come back, and even if I'm taking a thermal picture alone, the moment I hit the trigger, the camera will save both thermal and digital at the same time. Now, if this is a common practice when I'm doing an inspection of going to the menu, accessing and switching different image modes to provide for more details, I can also set up the AI button for that. But since I already set this up to change my scale mode, I can go to the front AI button or the one in the bottom part, which is right here. The operation is the same. I will press and hold. I will see the options in my menu. And for this one, we're gonna switch image mode. I will press enter, and after pressing that button a couple times, on the third time, you will see that it's switching to blending. Press once more, I have picture-in-picture. Once more, 13 megapixels. Once more, 5 megapixels. Sorry, 5 and 13. Picture-in-picture, side to side, and back to thermal. For dark environments where I need to provide a secondary digital picture, it is recommended to use the flashlight. I can use the flashlight to navigate across dark environments and use it as an additional tool that I don't have to hold on my hand. Or I can also set up the camera to open this flashlight at the moment of taking the picture. For that, I will go to Device Set, LED or LED lamp as flash, turn it on. And then at the moment of taking a picture, the camera will also activate the flash so that I have a better illuminated picture. Once again, I will show you in one of these images. You will see how the flash is being activated right there. When taking thermal pictures, some annotations can be done. Let's say that I am ready to take the picture. I hit the picture taking button and the image is frozen. At this point, I can add tags. A tag can be input manually by tapping on the keyboard, but it can also be added by scanning a QR code. Once again, the second application of that flashlight is to help visualize clearly in dark environments those QR codes. Let me show you how to use that. One more application of the digital camera and the flashlight is to add additional details to my thermal pictures. Let's say that I freeze this image and I want to add a tag so I can filter that image later. I will open the tags menu. I will open the QR code scanner, which uses the digital camera, and I will directly open and direct it. Another application of the digital camera is to provide additional information to my thermal pictures. Let's say that I capture this image and I want to add a tag that I can use to filter. There are different options. Right now I'm going to open tags. A tag can be input manually by using the keyboard on board, or I can also use a QR code scanner. By directing it at a given QR code on the equipment, the camera will capture the information in the QR code, which I can now save and use it as a way to mark my image. All I have to do is press once more to save that image. I can also use barcodes. Once again, all I need to do is freeze the image, open the tag area, open the scanner, and this time scan a barcode instead. The information of the barcode is saved as a tag. I hit save once more, picture taking button again to save that image. Another way to take advantage of the digital camera on the camera is by using OCR, a technology that recognizes text and inputs it into the system. For that, it is necessary to first connect the camera to the Wi-Fi. So in settings, I'll go to connection. I will turn on the Wi-Fi, let the camera search, and connect to a given network. Right now, the camera is connected. I will freeze the image once more with the picture taking button, go to tags, and in this occasion, I'm going to turn the OCR. You can see that there is a different type of box. I can aim it at a given text, let's say electrical panel or the given inventory number. I need to reduce the size so that it only focuses on a given area and it doesn't capture everything else. I will take the picture. It will take a couple seconds and now it has captured that text for me. I can confirm it and save it back, and the picture is saved with a tag. Non-regular panel or asset names can also be used. Once again, I take the picture, I go to tags, OCR, I'm going to scan this one. I will adjust the size of the area that I want to recognize text from. I'll take the picture, and then I have panel 15-B confirm. That is saved once more, and the picture has been saved with a tag. Now, as you see, this is a very useful feature on the camera that if I decide to use frequently, I can also set it up in one of the AI buttons, the front one or the one on the back. All I need to do is press and hold the AI button. But if I try to search here, I will only find features that can be used during the picture taking interface. But if I want the QR code tag or one of the tags, first I need to freeze the image because I can use a different set of features for my AI button. I will press and hold, and over here I will see specific features for when the picture is frozen and I want to modify it. So once again, I'm gonna go, let's say, OCR tag, and I press the AI button twice so I can start doing that, okay? Let me find a different one. In this case, I'm gonna do electrical panel. I'm gonna adjust the size of my window to make sure that I only get the text that I'm interested in. Right there, actually, let me just add location as well. I'll take the picture and it says location, electrical panel, which is exactly what I had over there. Confirm the tag has been saved and I can continue. Now see how easy it is. Picture frozen, AI button, aim at a given area, take the picture, let the camera recognize, confirm. As a result of doing this, the inspection goes faster because I don't have to take notes. Now when I go to the gallery, I can filter my images by specific assets. I can have, for instance, the panel 15B and the picture that was taken for that one. Or I can go to the EP4563 asset, confirm, and it will show me all the pictures that have been taken for that specific asset. An additional way to add comments to my pictures is by freezing the image, tapping on the menu, opening the voice recording feature, tap on the recording part, say 1, 2, 3 recording, and the picture has already been saved together with a voice annotation that I can listen over here. Once again, the volume can be adjusted so that I can listen to it from the speaker. Just save it right here. From the drop-down menu. So I can adjust the volume, which will be noticed both on the speaker and the earphones. One more way to enhance the visibility and experience using the thermal camera is by adjusting the brightness on the screen. I will scroll down from top to bottom, and I will scroll on the brightness control. All this video has been recorded by using just half the brightness of the screen. For operations outdoors with sun glare, this is a good way to adjust and improve the visibility of the camera. An important part of understanding thermal images from a qualitative perspective is the use of color, and that is why the camera comes with multiple thermal palettes that can be used on board. I can go from gray, iron to gray, to rainbow, to rain. There are different options that are commonly used on the top line, but if I tap the 3 dots, I would also see additional palettes. There is a total of 17 palettes that can be chosen from. However, it is common to find palettes like the gray one or black and white, where hot is represented with white color and cold is represented with black color, and a second palette to be represented the opposite way. However, the way to do this on a FOTRIC camera is by inverting all the palettes. So not only we have 17, but actually 34 palettes in total. If I tap this, all of them will be inverted. So now the same palette turns into black for hot and white for cold. Different palettes offer insights into different industries or applications. For instance, for electrical applications, it's common to use an iron palette. For applications where there is very little thermal contrast, we tend to use palettes with more color. For instance, we can go to a rainbow palette. In this case, it's not very useful because I have a very focalized temperature area. But if I were to move around, I will gain additional colors that will show me small temperature differences. This palette is particularly useful for building applications to understand temperature distribution as a representation of moisture intrusion or missing insulation. Palettes like the ones called Gray 10 or Rain 10 will offer additional contrast as a way to start an inspection. In the bottom part of the palette, we have the isotherms. Isotherms that correspond to above temperature, below temperature, and intervals. These three palettes are also known as color alarms. The first one, the above alarm, works in this way. You will see that now I have a gray palette. In the top right corner, there is a value which represents the threshold from which this palette will start showing color. So I can use one measurement tool right here. It's telling me that that area is at 107. So I will tap to make sure that number is highlighted in blue and bring that number below 107. This palette is used when I want to inspect for dangerous temperatures on a specific equipment. I will run a general inspection across the room, and as soon as the temperature reaches, surpasses the threshold, I will clearly see it on my screen. The second isotherm is the below temperature alarm. This palette will show me colors only if the temperatures are below the given threshold. This is a common palette used to identify condensation on specific areas. A common practice is to use an hygrometer to identify the dew point in a given room and input that value over here. As you can see, as I lower that value, I can clearly identify the surface on that cup that is full of iced water, which after some time I will know for sure, just using the thermal camera, it will condensate on its surface. This is a quick way to identify problematic areas in a given wall. And lastly, we have the interval isotherm. This is a way to identify specific temperatures that can be problematic for, let's say, certain production problems. We want to make sure that certain equipment is above certain temperature and certain equipment below certain temperature. So what I'm going to do here is to isolate those two and try to make sure to show only this one. So I know that my cup is around 110, so I want to have 110 between those two values. Now, when the two values are highlighted in blue and I use the directional keys, I will move the level. And if I touch one of them at a time, I will adjust the span. So as you see right here, by doing a quick scan around the area, I can identify the specific area of interest. If I want to even isolate this one alone and remove this one, I know that anything above 110 needs to be removed. I'm going to lower that level and remove it slightly. Well, right now these two are very similar temperatures. Now, another additional tool that you can use when you're using isotherms is the blending mode. When having blending mode, something around 70 to 60%, and remember to always focus the camera to make sure the two images match. This will help me to quickly understand and identify which are the components or equipment that I am identifying with the isotherms. After a picture has been taken, I can also modify the palettes from the gallery. So I will go to the gallery, I will open the image that was previously taken, and by tapping on the three dots and then on the additional three dots, I can access the gallery of palettes. Once again, I can identify which palette can provide with better insight into my image. I can also invert them and see which are the ones that could provide with more details. After this has been done, if I want to save the image, I will press back and make sure to hit the save button. I would like to show you how to access the data of your camera using different interfaces. First of all, we're going to go to the bottom part of the camera where we can see the connections interfaces. We're going to see a power charging interface. We will also have a USB-C. We will have a mini HDMI, and lastly our SD card slot. I will start there. To remove the SD card, I just need to press and remove the SD card. This SD card can be read with the SD card reader that comes along with the camera. This is probably one of the most convenient ways to keep your data organized if you are a service company with multiple clients. You can also have different SD cards for different projects. To place the SD card back, all we need to do is to insert and press. For this type of SD card, it's not necessary to turn off the camera to remove and insert the SD card again. Now let's see the USB-C. This cable is used to access also the gallery and all the storage of the SD card, but by using the camera as an interface. I will simply connect the cable and do that. The USB cable also allows users to control the camera from Analyze IR software to use it in the way or similar to a fixed mount camera. We can, for instance, mount the camera using this interface for the tripod, and then connect the camera to the computer and control the camera for a long period of time using a wired connection. Lastly, we have an HDMI connection. It is very important to remember that this is a special cable that comes along with the camera. Different cables bought from different sources might not provide the same performance. The mini HDMI cable will go on the camera, and then this side can be connected to a display screen or also a projector. With an additional adapter, special adapter, can be also used to import the video of your camera into video calls like Zoom or Microsoft Teams. And that's it. I hope that you can take advantage of all these different features on the camera and start doing your inspections.